Okay, hi students. So today we are going to continue our lesson for the fifth Laplace inverse of transformation, inverse Laplace transformation. You have your notes, okay, so in front of you. So we have number 5 property, which is inverse Laplace transform of derivatives. Okay, inverse Laplace transform of derivative.
Besar sikit.
Okay, so we wanna do Laplace transform of derivatives. Okay, so what is Laplace transform? So normally we have Laplace inverse of Fs. We will get Ft. Okay. So previously we have now we have to, what if we have Laplace inverse of derivatives of Fs. F prime means derivative. Okay, so dalam notes, if in the notes we have negative 1 T F Ft. Okay, this is the property in your notes, right? So this is if we have of 1, okay? So in general, if you see in the notes, if we have Laplace inverse of more than 1, then we have if we have more than 1 in general, so that you can see yourself in the notes. Okay, so let's go through the first example, A. Okay, so we have Laplace inverse of can't you see, this is natural log. Okay, 1 over S over S minus 1. Okay, so far before this we don't have this kind of function, natural log. This is new to you. So what we do is, if you have question involving natural log, we have to modify first, because we don't have natural log in your table. Okay, so that means we have to first modify the log with log's rule. Remember log's rule for division? So we have log S minus log S minus 1. Okay, so we just modify first without inverse yet. Okay, modify first, and then we can Laplace inverse separately. You see, we inverse it separately. Okay, later on. Okay, so now we don't inverse yet, because we don't differentiate yet, because we want to use F prime, differentiation property of derivatives. Okay, so what we do is we differentiate whatever we have in this. So we differentiate log S to make easier to inverse. Okay, so log S differentiate, we have 1 over S, and then 1 over S minus 1 for this. So we have to differentiate again S minus 1. So S minus 1 is 1, so 1. So when we do the differentiating, after we do the differentiating, this is differentiate this, we differentiate F here, Okay? Sorry, Fs. When we differentiate, what happened? Laplace inverse differentiate function in respect to S. What happened? So we just differentiate only once just now. So your n is 1, negative 1. So t, f, t. It becomes like this. When we differentiate, so use the property, it becomes like this. Okay? So now, we want to find, the question is, we want to find ft. This is our ft. Sorry, this is our fs. So, the question on ft, right? So, where is ft? Right here. This one is ft. So, this will become the answer for the inverse of fs. This is quite different, how to approach this one. It's quite different from the previous. Is that clear? Okay, so now then we want ft. We have ft over here. So this one ft. Okay, so now we solve this. So we can solve this, right? Laplace inverse 1 over s is 1. Laplace inverse 1 over s minus 1 is e. A is 1, so et. Like that. Okay? So this one is negative t ft. So now we have ft is 1 minus et divided by t, yeah, negative t. This one, divided by negative t. So we have ft. So this is the answer. Like that. This is how we do natural log. Normally, natural log, you just differentiate only once. So you don't worry about the rest of the differentiation, the order of differentiation. Biasa, normally we just differentiate only once. Yeah, we just ask you to differentiate only once. Don't worry. Okay, this is how we use we inverse natural log. Okay. Okay.